Okay, so our notes today are on driving data. Okay, so we have quite a few definitions we're going to go through. Okay, so the first definition, and you'll see some of these key terms in the problem. Okay, so that's why I want to go over them and just make sure you guys understand what they are. So the first one is the odometer. So this is the device or the gauge that is indicating the total distance a car has traveled. Okay, now there's two types of odometers. One of them is can be electronic. This is more like in modern day cars, and this gives the reading electronically. So this is when you have electronic reading or digitally. Another way we could say it. Okay. Now, way back in the day when they used to make cars, they used to have a mechanical odometer. So it was almost like where they had little uh, the numbers were on little like wheels inside, and they kind of spin and they turn as the miles accrue. So the mechanical odometer gives the reading mechanically. Both achieve the same thing, which is tracking the total miles on the car. Okay, but you'll likely probably see this kind of mechanical odometer in like more like classic cars or cars maybe built maybe in the 70s or 60s, maybe even early 80s. Okay, seems like once we got into the 90s, they started making more cars with these electronic ones. Okay, now there's also something called a trip odometer. And this is a odometer that we can reset to keep track of just a single trip. So, for example, if you were, say, taking a trip to Arizona and you wanted to know how far you drove, you could set your trip odometer, and then that would just keep track of the miles for that particular trip. Okay. Now, the odometer, it can be useful in keeping track of miles for us. That way, we can take a look at what is our fuel efficiency for a car. Okay, and we are going to be doing some problems with fuel efficiency today. Okay, we also have something called a speedometer, which I'm sure most of you guys are a little bit more familiar with, but this is the instrument that tells how fast you are traveling. Okay, so this will tell you like you're going 50 miles per hour, 60 miles per hour, 20 miles per hour, so forth, right? Okay, now the next definition is for fuel economy measurement. And a fuel economy measurement is going to tell us how efficiently our car is using gas. Okay. Now, when we're using these fuel economy measurements, in the US, we tend to measure in miles per gallon. So we talk about how fuel efficient is our car, how many miles per gallon does it get, okay? And we calculate this by taking the number of miles and dividing it by the number of gallons of gas that we're using. Okay. And so the higher the miles per gallon, the more fuel efficient our car is. The lower the miles per gallon, the less fuel efficient the car is. Okay. Now, if you ever go to other countries, most other countries do not measure miles per gallon. They measure in kilometers per liter. So, for example, if you go down to Mexico, all the road signs there, the speed limit is not in miles per hour, it's in kilometers per hour because that's what they measure, and they measure in kilometers. And when you go to the gas station, they don't sell the gas by the gallon, they sell it by the liter. Okay. So kilometers per liter, we get the fuel efficiency the same way. We divide the number of kilometers by the number of liters. Okay. But this is what most other countries use. Okay, we don't use this measure in the US. Okay, if you were going to ever go to another country, that would be the measure that they would use. Okay, now the reason why is here in the US, we use the English Standard System. So this is the system of measurement that we use in the US. Okay, so we measure things in feet and inches and yards and miles. Okay, we also measure in gallons, we measure in pounds. Okay, this is our English Standard System of measurement. Okay, now mostly almost everywhere else in the world, like almost every other country in the world, uses the metric system. So this is the system of measurement used pretty much everywhere else. Okay, so today we're going to be working with some formulas. Okay, and our formulas are we're going to have basically two different distance formulas that we're going to be working with today. Okay, so we're not going to talk about currency exchange rate here. Okay, so you can line that out or you can delete that. Okay, but our first distance formula that we're going to be talking about is this one, D equals R times T. Okay, and in this distance formula, the D stands for distance. The R stands for rate, which is really like our speed, how fast we are driving. And the T stands for time. And this is generally a number of hours. Okay. Now, we use this distance formula when we're given problems involving speed. Okay, this is the formula that we're going to be using. Now, there's another formula that involves distance that looks like this. D equals M times G. Okay, and in this distance formula, the D still equals distance. Okay, but the M stands for our miles per gallon. And the G stands for the number of gallons. So we use this distance formula when we're talking about fuel efficiency, okay? So this one here, we're going to be using when we're dealing with fuel efficiency. And this one here, we're going to be using when we're dealing with speed, okay, or how fast we're traveling. Okay, so two different formulas for two different situations. Okay, so it's important that when you're reading through these problems today, you take a look and you see kind of which situation it's applying to. Okay. Okay, so let's go ahead and let's take a look at problem number 1. Okay, so problem number 1 says a car travels at an average rate of speed. So we're talking about speed here. It's already given us this word speed. Okay, of 50 miles per hour for 6 hours. How far does this car travel? Okay, so let's underline some of the important information. It told us that the speed was 50 miles per hour. So remember, speed is our rate, okay? So this number here, 50, this is going to be my value for R, okay? Then it gave me, it's traveling for 6 total hours. So remember, our time is generally in hours, so this is going to be our time. Okay, the question, how far does the car travel? So it's asking you how far. This is asking you about a distance. So we're trying to find out our distance. We do not know the distance. That is what we're trying to find out. So we have 2 of the 3 variables. So let's plug in what we know. We'll leave a variable for what we don't know, and then we'll solve this equation. Okay, so we're going to just plug into this equation, d equals r times t. So the d is unknown. The r we know is 50, and the t is 6. So let's go ahead and multiply. Okay, and then see what you guys get. I'm thinking you guys probably got 300 for that. Now remember, it's not just 300. We need to write some kind of unit of measurement. And since we're talking about a distance, we here are measuring in miles in this problem. So we're going to write miles. Okay, so 300 miles will be our answer for that. Okay, we're going to go over how to solve this one. So this one, you see, it says Erica is traveling at 83 miles per hour. So here is her speed, right, which is going to be our rate. Okay, for 3.5 hours. So this is her time right here. And if it's okay, I'm going to use 3.5 for my time instead of 3.5, just because half, it's a fraction, right? It's equivalent to 0.5, but it's hard for me to put that in my calculator. So I'm going to use 3.5. The question, how far does Erica travel? So this is asking me her distance, okay? So I'm going to go ahead and I'm going to plug everything in. D is unknown, equals R, which is 83, times 3.5, okay? And I'm just going to go ahead and plug that into my calculator. And when I do that, I get 290.5. And remember, I'm finding a distance. So a lot of you guys did do a good job of making sure that you wrote miles down. So if you didn't get the miles, let's make sure you write them down because we do want to have a unit of measurement in our answer. Okay, number 3. Okay, so number 3, it says Jack lives in New York and will be attending college in Atlanta, Georgia. The driving distance between the 2 cities is 883 miles. Okay, so it looks like they're giving us a distance right here. Okay, Jack knows the speed limit varies on the roads he will travel from 50 miles per hour to 65 miles per hour. He figures that he will average about 60 miles per hour on his trip. So this is his rate right here. We're going to use this rate for his rate because that's what he's averaging for his speed. Okay, at this average rate, for how long? So it's asking me for how long will he be driving? So our time in this problem is unknown. Okay, express your answer rounded to the nearest tenth of an hour and to the nearest minute. Okay, so let's go ahead and plug in everything we know into our formula d equals r times t. Okay, the d this time, the distance is 883, so we know that value. We also know r is 60, and we don't know t, so I'm going to leave that as an unknown. Okay, now, what do we want to do to solve this problem? Because in the last problem, we just multiplied, but now our variable's on the other side here. So we need to do the opposite of multiplying. What is the opposite of multiplication? Well, it's division, right? So let's go ahead and divide both sides by 60 and see what we get. Okay, now I'm going to go ahead and divide by 60. I'm going to get my calculator out. And let me see what we end up with. Okay, we get 883 divided by 60. So that's 14.71667. It told me to round my answer to the tens place, which means I'm going to cut it off right there. And I'm going to look at this number. It's telling me to leave the 7 alone. So I'm just going to use that t is about equal to 14.7. And it's a time, so this is in hours. Okay. Now, one of the things that it also told you to do was it said find it to the nearest tenth of an hour and to the nearest minute. Okay. So it wanted us to also find how many minutes is this portion of the hour. Okay. So in order to change a portion of the hour into minutes, okay, we're going to multiply that portion of the hour by 60 because there's 60 minutes in an hour. Okay. And the reason why we're using 60 has nothing to do with the 60 in this problem. Okay. A lot of students were confused about that when we went over that. So it doesn't have anything to do with this. We always multiply by this constant rate of 60 because there's always 60 minutes in an hour. So when we're finding the portion of this hour is zero point 0.7. Okay. We're going to take that and we're going to multiply it by 60 to give us the total number of minutes. Okay. So when you do that on your calculator, you will get 42. So 7/10 of an hour is really 42 minutes. Okay. So another way to write this answer is we can also write 14 hours and 42 minutes. Okay. If we wanted to know exactly the time in hours and minutes. For number 4, it says Danielle drove from Atlanta, Georgia. This is a typo here. It's supposed to say to Denver, Colorado, which is a distance of 1,401 miles. So this is telling me the distance right here. So I'm going to use this number as my distance. Okay. Then it says if she averaged 58 miles per hour. So when it's telling us miles per hour, that's meaning our speed. So this is going to be our rate, okay, on her trip. How long is her driving time to the nearest minute? So it's asking us how long is her time, okay? So this is wanting to know the time. So that is the unknown, okay? So let's go ahead and plug in everything into this equation, d equals r times t. And we're going to go ahead and plug in our distance, 1,401, equals our rate, which is 58, times our time. Okay. Now, just like in the last problem, we're going to undo this multiplication by dividing on both sides. So go ahead and divide on both sides and see what you get. Okay, so I'm getting 24.155. I'm going to round it to the tenths place, so that would be here, except I need to look at this 5. It's telling me to round the 1 up, so I'm going to use 24.2. Okay, now it told me to find my time to the nearest minute, so I want to take this portion of the hour and change it into minutes. So I'm going to take 0.2 and multiply it by 60 minutes because there are always 60 minutes in the hour. Okay. And so when I do that, I get 12. So it's 12 minutes is my portion of the hour. So another way to write this answer is 24 hours and 12 minutes. Okay. So 2 ways to write the answer. Okay, so for number 5, it says Kate left Albany, New York and traveled to Montreal, Quebec. The distance from Albany to the Canadian border is approximately 176 miles. So they're giving you a distance here. Okay, the distance from the Canadian border to Montreal, Quebec is approximately 40.4 miles. So they're giving you a second distance. Okay. If her entire trip took about 3¾ hours, so this is looking like a time here. Okay. What was her average speed? Okay, so the question is asking about average speed for the trip, which means we are looking to find the rate. Okay, because speed is a rate. Now, do you see how in this one they gave us two distances? They gave us this distance was like the second leg of the trip, and this distance over here was like the first leg of the trip. So we need to take those two distances and combine them. So let's go ahead and combine the 176 and the 40.4 so that we have one distance to work with, okay? Because in her trip, she drove first to the border, and then from the border, she drove to the final destination. So we've got to put those two distances together, okay? So here's what we get when we put them together. Okay, so we're going to use this value for our distance, okay? Now we can go ahead and plug everything in now that we have our total distance. So we're going to do distance equals rate times time. Is it okay with you guys if for my time I use 3.75 instead of using 3/4 as my fraction? You guys understand how I got 0.75 there? If I just take 3 divided by 4, it gives me 0.75, right? 3/4 is equal to 0.75. Okay, so for my time, I'm going to use 3.75. Now, this is multiplication here. So what's the opposite of multiplying? We're going to divide on both sides. Okay, and I'll get my calculator out to help me with that. Okay, so I get 57.70. So I want to cut it off right there. I'm going to look, the 0 is telling me to leave the 7 alone. So I'm going to say it's about 57.7. Now, this is my rate. So remember, when I'm talking about rate here, I'm talking about miles per hour. Okay. So that would be my final answer for that one. About 57.7 miles per hour. So did I answer the question? What was her average speed? The average speed was about 57.7 miles per hour. So yes, I answered the question. So number 6, Juan has a hybrid car that averages 40 miles per gallon. His car has a 12-gallon tank. How far? So this is what it's asking us, a distance, right? Can he travel on one full tank of gas? Now, in this problem, are they talking about speed at all? Is it saying anything about miles per hour? No, okay? So remember, going back to those two formulas we wrote down, one of them was about speed, which is D equals R times T. One of them was about fuel efficiency, which had to do with miles per gallon and gallons of gas, right? So for this problem, it says miles per gallon and gallons right here of gas, right? It's like how many gallons can his gas tank hold? So we're going to use the other formula, which is the D equals M times G for that, okay? Now remember, in that formula, M was the miles per gallon, so we're going to use this for our M value. And G was the number of gallons of gas that we're using, so we're going to use this for our G, okay? So we're going to go ahead and plug in the values that we know. We don't know the distance because that was the question. The miles per gallon is 40 times the number of gallons of gas was 12. So let's go ahead and multiply, see what we get. Okay, so 40 times 12 is giving us 480. And remember, it's asking us how far. So how far means our answer is going to be in miles. he can travel 480 miles on 1 full tank of gas. Okay, so number 7, Lily drove a total of 416 miles. So miles, this is a distance, on 13 gallons of gas. So 13 gallons of gas. This is going to be our value for G. Okay, question. How many miles per gallon does Lily's car get? So it's asking about the fuel efficiency of her car. So this is our miles per gallon. Okay, let's go ahead and plug everything into our equation D equals M times G. So I have D this time. I do not have M. I do have G. G is 13. Okay, so the opposite here, multiplying. Let's go ahead and do the opposite operation, so divide. And let's see what we get. Okay, this one was nice because when we divided, we didn't get a decimal. So we got M was 32, and the question was how many miles per gallon? So we're talking about fuel efficiency. So 32 miles per gallon is the fuel efficiency of Lily's car. Okay. Okay, so for number 8, it says, when Barbara uses her car for business, she must keep accurate records so that she will be reimbursed for her car expenses. When she started her trip, the odometer read 23,787.8. Okay, that's a number of miles, right? Because odometer, remember, it's keeping track of her distance, her total distance her car has traveled. When she ended the trip, it read 24,108.6. So this is how many miles she started with on her car at the beginning of the trip. This is what she ended with. Okay. Barbara's car gets 32 miles per gallon. So this is her fuel efficiency right here. Okay, her tank was full at the beginning of the trip. When she filled the tank, it cost her $40.10. What price did she pay per gallon of gas on this fill up? Okay, so the final question is asking us about price, right? Okay, now we haven't done any problems yet with price. Okay, so let's think about the types of problems we have done so far. We've done some with speed, and we've done some regarding gallons of gas and fuel efficiency. Did they talk about speed at all in this problem? No. Did they talk about gallons of gas or fuel efficiency? Yes. Okay, so we are going to start by using this formula, the D equals M times G. Okay, now for the distance, they gave me 2 distances here. Now I know there was a problem where we added the distances, but this one is telling me what she started with and what she ended with. So we're actually going to subtract these to find her total distance. So for her distance, we're going to take what she ended with on her odometer and subtract from it what she started with, and that will tell us how far she traveled. Okay, so when I go ahead and subtract that on my calculator, I get that she traveled 320.8 miles. Okay, so this is going to be my distance. Okay, I'm going to use that number for my distance. Now, the other thing they told me was they did tell me her fuel efficiency, how many miles per gallon she gets. So this number right here, the 32, is going to be my M. Okay. Now, out of this equation, D equals M times G, I'm missing the G. So let's try to find the G. Even though that's not my final question, I'm hoping that by finding this, it will help me answer my final question. Okay. So let's go ahead and plug in everything we know. 320.8 equals the miles per gallon times G. Okay, I'm going to go ahead and I'm going to divide by 32 on both sides. Okay, when I divide, I get this for my G value. I'm going to leave it exact for now, okay, because it wasn't too crazy of a decimal. So I get that on this trip, she's using this many gallons of gas, okay? Now, it tells me that she filled up the tank at the end of the trip and her price she paid for this many gallons of gas was $40.10. So the final question is asking, how much did she pay per gallon? Okay, so it's asking me to figure out the price per gallon of gas. And in order to figure out the price per gallon of gas, I'm going to take the price and divide it by the number of gallons she purchased. Okay. So what is my price that she paid? $40.10. How many gallons of gas did she purchase? Well, she replaced everything she used, right? She filled up. So she purchased 10.025 gallons of gas. Okay. So let's go ahead and divide and see what we get. And when I divided this, I was like super shocked because I thought it was going to give me some crazy decimal. But it was actually really nice because when I divided, I got a nice number, 4. So this is $4 per gallon of gas. That is our price. $4 per every gallon of gas. Okay, so each gallon of gas costs $4. So that is our final answer for that one. And I know that one was a little complicated because you have that price thrown in at the end. Okay, but it was just asking us to take the total gallons we got and then using this price, divide those numbers so we could get a price per gallon.